surface texture, and leveling defects are among the most common and critical issues in solvent-borne automotive coatings, and understanding them requires a detailed view of the coating's behavior from application to full cure. In these systems, the interaction of solvent evaporation, viscosity rise, surface tension, and gelation determines whether the coating will flow into a smooth surface or lock in unwanted texture. Immediately after spraying, solvent begins to evaporate both from the surface and within the film. This initiates a dynamic process in which the coating transitions from a low viscosity liquid to a semi-gelled, structured film. During this period, surface tension drives the coating to level, while rheology modifiers help maintain proper shear thinning and recovery, allowing the film to flow without sagging. The critical window, often called the leveling window, is the period when the coating remains mobile enough to flatten before gelation restricts movement. If the surface skins or cures too early, defects such as orange peel, poor leveling, stippling, overspray, roughness, or low gloss become locked into the film, regardless of downstream curing. Orange peel is the most frequently observed surface texture defect in high solids base coats and clear coats. It manifests as a repeating pattern of peaks and valleys, resembling an orange's skin. Detection is most effective under directional lighting or reflection tunnels, where the distortion of reflected images highlights the defect. Orange peel is often misdiagnosed as a spray problem alone, but it is typically a combination of formulation and process issues. On the formulation side, high low shear viscosity, insufficient wetting, and rapid solvent loss can cause the surface to skin before the film has completed flow. A solvent blend with too many fast solvents reduces open time, while inadequate medium or slow solvents prevent the inner film from remaining mobile. Excessive film thickness traps solvent beneath a rapidly skinning surface. Process factors, including spray equipment settings, atomization pressure, booth, and panel temperature, also play significant roles. Cold panels increase viscosity and reduce leveling, while hot conditions accelerate skin formation. Flow and leveling additives, typically modified polysiloxanes or acrylic chemistries, can help by lowering surface tension gradients and promoting wet film mobility, but their effectiveness is limited. Overdosing can introduce craters or fish eyes. In RD&I practice, additives are used only after solvent blend, viscosity, and film thickness are optimized. Minor orange peel can be corrected by sanding and polishing, while severe occurrences often require reapplication under controlled conditions. Poor leveling is an early or borderline form of orange peel. The surface may appear visually flat, but shows subtle waviness under side light. It occurs when the coating nearly completes flow, but loses mobility just before final smoothing. Root causes include slightly elevated viscosity, insufficient tail solvents, or reduced flash-off times. In an OEM plant, poor leveling is a warning that the process is nearing its control limits. Minor deviations in temperature, film thickness, or application speed can cause full orange peel. Low-dose leveling additives can slightly improve the surface, but they cannot replace fundamental process or formulation control. Troubleshooting focuses on balancing solvent blends, controlling film thickness, and maintaining environmental parameters within specification. Stippling presents as a fine, uniform short wavelength texture and is often confused with orange peel. It is primarily caused by spray mechanics rather than formulation. When atomization pressure is too low, nozzle size is mismatched to viscosity, or spray distance is excessive, droplets partially dry before reaching the panel and fail to coalesce completely, forming a frozen, pebble-like texture. Additives cannot correct stippling. Prevention relies on correct gun settings, air pressure, nozzle selection, spray distance, and temperature control to maintain film fluidity. Mechanical correction through sanding and polishing is usually required. Overspray roughness occurs when partially or fully dried airborne particles land on a semi-cured surface. These particles cannot redissolve and remain embedded as surface roughness, commonly appearing on panel edges, recesses, or areas with uneven coverage. Like stippling, this defect is process-driven, and additives offer no solution. Prevention involves careful control of spray distance, overlap, gun speed, maintaining a continuous wet edge, and operator training. Minor roughness can be corrected by nib sanding and polishing, whereas severe overspray requires a recoat. Low gloss due to surface texture is an optical consequence of micro roughness rather than a chemical failure. Even when fully cured, micro texture scatters light, reducing specular reflection. Orange peel, poor leveling, stippling, and overspray roughness all contribute to gloss loss. Flow and leveling additives may slightly smooth the wet film, but true gloss recovery requires addressing underlying causes. RD&I analysis typically evaluates surface topography, solvent evaporation profiles, viscosity control, and environmental conditions to ensure complete flow before gelation. The key principle across all surface texture and leveling defects is the timing between solvent evaporation and viscosity rise relative to the coating's flow window. The coating must remain mobile long enough for surface tension to flatten the film before curing limits movement. Critical control parameters include solvent evaporation rate, viscosity during and after deposition, film thickness, booth and substrate temperature, and judicious use of flow and leveling additives. When these factors are correctly managed, defects are minimized. When misaligned, the defects appear consistently and serve as diagnostic indicators of formulation process misalignment. Understanding these dynamics allows plant operators, formulators, and RD&I engineers to identify root causes, implement corrective actions, and achieve high-gloss, defect-free surfaces. If you have any doubts, questions, or specific plant floor issues related to surface texture and leveling defects, please leave them in the comments. Future episodes will address these questions with practical OEM troubleshooting strategies and deep RD&I insights.